Hey, hello, and welcome to the show. It's me, JP. It's time for JP's product pick of the week. Thank you so much for stopping by. Here we are, and I've got a cool new product for you today. We've got it at a deep, deep discount. If you want to go take a sneak peek, head right there because that's the product page. You can go to that QR code. You can go to that URL right there. And this show takes place right inside of that page, so you won't miss anything. There's no coupon codes involved, so if you want to grab it at the discounted price, I know we had 100 that were just put back into stock, and we have them at 50% off today. You can get a maximum of 10 per customer, no resellers allowed. No coupon code, like I said, just throw them in your cart and buy them before the end of the show or before they sell out. We don't take rain checks. So what I'd like to do before I get going is thank you for joining over in the chats. We've got some people over in our YouTube chat. Hello to Robert Cochran and R. Brian Lindahl and Dave Odessa. Thanks for stopping in over there. Lars is just having a conversation with a dinosaur as far as I know, but I try to stay out of it. If you are wondering where the chat is, if you're somewhere like Facebook and there doesn't seem to be an active chat, that's probably because people are over here, right there. That's where they are in our Discord. You can go to adafruit.it/Discord. You'll get an instant invite. You can look for that live broadcast chat channel right there. That's where it's going on during the show, but then there's plenty of other channels you can check out for other topics. And hello there to John Nodge and Cooper and Todd Bot. Hello, Steve Grover, howdy. Hey, Blitz City DIY. Thank you for jumping in. So without further ado, let's have Lady Ada talk a little bit about this product pick from the Ask an Engineer new segment just a few weeks ago. So take it away, Lady Ada.
The QMC 5883 magnetometer. Now, we have a lot of magnetometers in stock, and so you're probably wondering, like, why do you have another one? Why not use the List 3DH or the List 2DH? I've seen this QMC 5883 used in a lot of quadcopters and robots, and I figured, maybe people want a little breakout. It's a fairly simple sensor. I do like it has fairly wide Gauss range. It goes from ±2 up to ±30 Gauss, and you can use it over I2C very easily. It doesn't have a very complicated driver. I go to driver in Arduino. We're going to have it available in CircuitPython and Python, so people can use this. There's also the QMC 5883L, but it seemed to be discontinued, and the P was the only subtype I could get. But still, I think, again, if you're doing robotics and you want something that uses this chipset, now you have something plug and play with STEMMA QT.
Yes, that's right. That right there. Where'd it go? Hey, look, it's still, I have one still in the bag. Let's open that up so I can talk about this thing. Let's get that out of there. This, yeah, right there. That's the product pick of the week this week. It is the QMC 5883P magnetometer. So this is a digital compass, essentially. It's a breakout board with I2C connectivity to your microcontroller. We have a nice easy way to connect with STEMMA QT/quick cable there. You can also solder in pins and put it on your breadboard or permaproto. And we've got Arduino drivers as well as CircuitPython drivers so that you can use this easily. It's simple, and it will give you a heading in essentially 3 dimensions. So you can do compass heading as well as inclination, declination if you want. You can also use it just to measure the strength of a magnet in any of those 3-dimensional space positions. And I'll give you some demos on there, but as Lady Ada said, it's straightforward. It's one that people like to use in quadcopters or drones and robotics to be part of the navigation system to tell where the Earth's true north is. Usually that's done alongside of other accelerometer, gyro types of IMU fusion, but this one is just the magnetometer. It has a wide range of sensitivities that you can use with it. So as Lady said, ±2 Gauss all the way up to ±30. And let's get to some demos of it. So let me pop on over to the down shooter here. I'll show you how this is set up. So you can see there, I've got the QMC 5883P plugged in over STEMMA QT to a feather board. And right smack dab in the middle of it, there is the chip. So what I have here for this first demo, this is actually a little screwdriver that I use, and it has a magnet in the end that's just used for holding bits in there. So I'm going to use that to demonstrate some readings on this. And if I bring up Z here, my code window, and I've got a REPL open there, you can see I'm measuring the magnetic strength and position in X and Y here, and just translating that into a little XY position on this grid. One of the things that I find is neat, hopefully you can see this well enough in this view, let me try to move things a bit, is you can set up something like a joystick with something like this. So if you hold a pivot point at the right spot, like I'm doing with my right hand there, I can use my left hand to move a little joystick around in space and get some XY coordinates. But this is also measuring Z as well, so you could do things with distance. So if you want to make like a little drawing tablet contactless, or put this under a surface, or surface with a little bit of give, you might be able to do sort of a Wacom tablet style measurement in a small space. This is not going to be a large space, but if you needed to do just a little sort of trackpad, micro trackpad kind of thing, it could be useful for that. However, the thing this is, before I move on, let's take a look at what's actually being read to do this. And actually I find the simplest example comes from the Learn Guide. Let's hop over to the Learn Guide here that Liz put together. And if you check the CircuitPython and Python section here, scroll down, you'll see a nice bit of simple code to test this out. Oh, excuse me, my scroll wheel went crazy there. So here you can see it's importing QMC 5883P. We set that up over I2C, instantiate the sensor. And then to read it, we simply ask for sensor.magnetic, and that returns the force in X, in Y, and in Z. And then these are being separated out into some separate variables so that can print nicely. So you'll see read out like this, X, Y, and Z, and it'll be negative, positive, negative, positive, negative, positive. So that's a nice simple example there. What I did was took that code and went and decided to do a little Compass prototype. So this was done with Claude Code, generative LLM. And if you go back here to Z, what I'm going to do is open up my other example, one second, which I called Compass Code. And I'm just going to paste that into code.py running on the Feather there. And let me start this REPL back up. This is actually going to ask for me to calibrate it by rotating it around at first, so I got to be ready to do that. So let's restart this. So calibrating, it just wants me to rotate in all directions for 10 seconds. Sometimes this will restart, just a USB issue. Hopefully it won't. Okay. Oh, let me make that window a little bigger. And hopefully you can see this. Yeah. So I've got some of the text I don't think you'll be able to see too easily. It's going to flash just because of the size of this window. But hopefully you can see my little ASCII art representation there. And as I adjust the inclination, declination there, you'll see that other axis on the right. It's a little off right now, and that's just because my calibration procedure is pretty crude, and there's probably a lot of magnets and things and metal in the space here. But you can see that's the general idea of what these are used for, is to measure the compass heading directions on the compass rows there, as well as incline and decline. So that's how they're used in things like quadcopters. And I just wanted to put together kind of a crude prototype there, just using Claude AI to come up with that. So if we go back to Learn Guide here. 3D Tech Guy over in YouTube says, "Sup, y'all? I'm actually in Germany right now." Hello, welcome, welcome to the chat. If you take a look at the main page here, you can see we had 100 in stock, and what I'm going to do is actually bring up my little stock ticker, so that's more accurate there. Let me refresh this page. We should see, yeah, we're down to 96 in stock. And they're $2.98. If you scroll down a bit, you'll always find we have a link to the primary Learn Guide. So going back to this Learn Guide here, we have the overview, and then the pin out here will show you the pins across the bottom there that you can solder to. We've got V in. There's a 3-volt out from the voltage regulator if you need that for something. And there's a common ground pin. And then we have clock and data for I2C. And then we also have that broken out onto these STEMMA QT pins. There's also a power LED. So if you look at my running example there, you'll see there's a little green LED lit up. You can actually cut a jumper on the back if you're using this in some application where you don't want to see that. You're building a little, maybe a compass heading lockbox thing for a mystery, and you don't want to spoil the mystery with a little green LED. You can cut that jumper that's on the back there. You see it says LED, just slice that with a hobby knife. And then, as I said, we've got CircuitPython and Arduino libraries for this. And it looks like Whippersnapper is coming soon. That page you'll see there is not published just because I'm in as an editor. But hopefully that'll happen in Whippersnapper too. And then in downloads, we've got the datasheet for the chip itself, as well as CAD for EagleCAD, a 3D model in GitHub that you can use for making enclosures, and there's also a fritzing object if you want to diagram that out. So those are that's what we have in the Learn Guide there. And let's last thing I'm going to do actually is go all the way back to the beginning. I just want to show the most basic example, just so we're not looking at the graphics I have on there, which can be distracting. So let's go back to this CircuitPython page here, and I can just copy the code from here, head back over to this window, and I'm going to resave this simple code. I don't know what is going on with my Z that it's underlining every line. I'm not sure what it thinks is happening. Let me close these other views. No, it's not that. I don't know what it thinks is going on. So if you look down here, as I said, we've got mag-y, mag-x, mag-y, mag-z are variables that are equal to the 3 values that come back every time we read sensor magnetic. Right now it's just happening once a second. I'll make that a little faster. So now you can see down at the bottom, let me hide this for a moment, it's getting, where'd my magnet go? It's getting X as I move side to side. So right now it's going from about -2 to +2. Y, -2 to +2, and Z, which is registering 0, and then down to 8 when I get very close to it there. So that is the sort of magnetic field, the Gaussian field there being read by the chip itself. And then you can use that for whatever you want, for examples like my little trackpad or the compass. All right, let's see. Anything else? I think that covers it. So thank you everyone for stopping by. Just checking if there's any questions in the chat. No, we're good. Okay. So that right there, where'd it go? Where's the other one? There it is. That right there is my product pick of the week this week. It is the QMC 5883P Magnetometer. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week. I will see you next time. Bye-bye.